Hello and welcome to a quick overview on using Knative and cloud events in the context of Drogue IoT. I would like to walk you through this overview with a very basic and very common example use case. You can always make it more complex, but let's start simple. We have devices with a temperature sensor distributed throughout the world, and we want to build a dashboard showing that temperature information. That means we must transmit the data to some central location and store it there. So a more technical view might look like this. The devices do a HTTP post request with a JSON in there every now and then. And on the server side, there is a process that will accept the data. It will store it in some time series database from which the dashboard will read the data. I will drop the dashboard from the following slides as I would like to focus on the actual payload processing. So here's some source code that I just made up, how simple that could look like. Now let's add a new device to the mix. Unfortunately, this one doesn't use HTTP, but MQTT, and of course it has a different data format and uses a different unit for the temperature value. So that is things that you might see in the wild. Still, we want to store the data in the same time series database and reuse as much as we can from our code. Stuffing that into the same box might work. However, just assume you would need to add a new variant there, so it pretty much gets complex right away. Or you want to add a new consumer to your data alongside the time series database. So that might make it even more complex. Using a modular approach would help here. So what we could do, we can create two endpoints, HTTP and MQTT, and they simply take in the data. We pass it to some converter service, which normalizes the protocol and the payload, and then we store it for further processing so that we can fork off a data stream later on if we need. And also we can buffer the data stream if the time series database slows down. We create a time series database writer, which only consumes the data and writes it to the time series database. Having a modular system like that, we could also move the boxes around and store the incoming payload directly. So we can handle conversion of the data later when consuming it. There are pros and cons on each way to do it, but with a modular system, you can mix and match as you like. So drawing such small boxes looks great, but how can you actually implement this? Yes, this is where Knative and cloud events come in. Knative is a Kubernetes-based platform for serverless workloads, but we don't focus on the serverless part here. Instead, we take a closer look at the Knative eventing component. If you read through the mission statement, you will get an idea how this can help. I recommend to check out the homepage for more information. Knative makes heavy use of Kubernetes custom resources, so most of the things you will see in a minute is being configured through YAML inside of Kubernetes. Let's start with the basics. Knative has a source and a sink concept. Others might call this producer and consumer, but it's basically the same. And while there's only abstract concepts, Knative also brings some implementations along. If you combine a sink with a source, you get something like a step in the middle. This can be used for transforming data before handing it off to the next destination. Knative also has a concept called flow, which allows you to compose new functionality out of existing blocks. Flows can be sequential or parallel. The sequence will run through its steps and provide a result in the end, which can then be sent to the next destination. The parallel flow only branches off an event into different streams. Of course, the sinks could again be some other sequence and can be more complex than shown here. Another concepts are channels and brokers. They are pretty much similar, so we will focus on the channel as it is the simpler construct. The main purpose of the channel is to persist or queue data, except for the in-memory variants, which don't actually persist data. Channels also offer some features like dead letter handling, and you can read more about them in the documentation. It is also possible for multiple sources to push data into a channel and for multiple consumers to subscribe. In order to get data out of a channel, you need to configure a subscription, which defines where the data should be sent to. If you like, you can add a filter to a subscription so that you can only get the events that you're interested in. So again, drawing boxes is easy, but the question is, how do sources and sinks actually communicate? And this is where cloud events come into the picture. Cloud events is a specification for describing events and how they are transported. There's a nice mission statement on their homepage, and I would recommend to check that out as well. That explains it in much more detail. So cloud events are the glue between sources and sinks. A cloud event contains some payload that can be JSON, text, or anything of binary data. It also has some standardized attributes like ID, subject, timestamp, etc. But more important, it also transports some information about the format of the payload and the schema of the data. The format would describe how the payload is encoded, in our case that is JSON, and the schema would define what to expect from that JSON. In our case, this is the simple temp field with the temperature value. And you can, of course, also add custom attributes as needed. Here we see an example on how this looks like in different encodings. First, we have a plain JSON encoding, which always comes in handy. And next, we have a representation as an HTTP request. We can see that Cloud Events tries to reuse the concepts of the underlying technology. So attributes map to HTTP headers, and the event payload is put into HTTP request body. Of course, there are some more technologies for which mappings have been defined. If we go back to our original diagram, we can try to implement this using Knative and Cloud Events now. And this is how it would look like. We have two endpoints, HTTP and MQTT. Both speak the native protocol of the devices that we use. As a first step, we wrap this into Cloud Events and directly store this into a channel, which would be backed by Kafka. We still have the different payload formats to deal with, but we do that later when reading from the channel. And when reading, we run the event through a set of steps. The first steps converts this into a standard temperature reading that we defined for our use case. And the second step converts this into a specific time series temperature event that our time series writer understands, so that the time series writer can focus on storing the data that it just received. Of course, there are many other ways to do this and how you could transform the data, but I hope you get the idea. Of course, you could implement the same architecture using other technologies as well. This isn't something new, but let's have a look at the benefits of Knative in this context. First of all, you can choose the programming language for each component. Knative services are Kubernetes services, and so you need to provide a running container. That's all that is required. But the choice of the programming language is yours. And this makes sense because your data might go through a pipeline of steps, each step taking care of a specific aspect of the data. However, each aspect might be treated by a different team, which is a different background. And they may prefer different programming languages, simply because it's more aligned with their context and their existing tooling. Another benefit we get is scalability. Knative allows us to scale up and also allows us to scale down again. And it can do that automatically as required. Also, we get the scale down to zero feature. So if there's no need to process any events, the deployment will simply be scaled down to zero. And when the next event comes in, it will be scaled up again. We also get versioning. So you can deploy different versions of your service and also split the traffic as we need it. So that you can do A/B deployments with that as well. The use cases we discussed so far assume that we publish some device-specific data format. But couldn't we just use Cloud Events directly from the device side? For some devices, that may simply not be possible because they already exist and it's hard to change their behavior. Especially in an industrial world, devices are rather big and expensive, so simply replacing them isn't an option. On the other side, making major modifications is a risk and costly as well. So the only option might be to simply accept their data format as is. But let's go back a few slides and look what would change if we would use Cloud Events from the start. Not too much would change. We would still have the issue of converting the payload, as most devices would probably still send their different payload formats. Also, the endpoints would still need to take care of some things like authentication and authorization of devices, rate limiting, etc. At the same time, asking devices to implement a more generic and more verbose data format will put additional strain on such devices. In the case of smaller embedded devices, this might be a problem. In the end, you're only shifting the effort away from a more powerful and more scalable location in the cloud towards smaller devices. Depending on your specific use case, that may not be beneficial at all. However, there's another scenario. Let's assume we have an edge-like deployment with an intermittent cloud uplink and some more compute power on site. We are locally aggregating data already, like for example an IoT gateway. We could accept the data as it comes in from the devices, pre-process it, convert the events and the payload into our standard format, and store it into a local Kafka channel. Once we are connected to the cloud side backend system, we are simply flushing out the outbox channel. And the cloud side doesn't need to take care of the different devices that we have on the edge side. It only needs to process normalized payload wrapped in cloud events. I hope you have an idea now what you could do with Knative and cloud events in the context of IoT. Thank you for watching.